Okay. All right. Thanks, Khadija. Um, I'm gonna go ahead and get started. Sorry, I have a kid doing school in the background. um, just a couple more weeks of us for virtual school. But anyways, so our speaker this month is Scott Shipley, the president of S2o Design. Scott is a mechanical engineer by training with a bachelor's and master's from Georgia Tech, but also a veteran of 3 Olympic Games and has now designed, I think, 3 Olympic whitewater courses, and a bunch of other ones. And I've kind of followed Scott's career just remotely through social media, and seen what he's done, the innovations that he's come up with. And I thought, although this is not a SLAMS topic, I think it's an interesting story, and I asked him to come talk to us today. Um, he's got, I think, like 30 or so slides, and so we should have time for questions. Yeah, thanks for coming and talk to us, Scott.
Hey, thanks for having me. Yeah, I just excited to talk to you guys. And Matt talked a little bit about how you all are a group of young engineers and kind of looking at how different people have gone down different career paths. And just thought I'd walk you through my story. It's very unconventional compared to a lot of people that are working at larger corporations are going through. But I think it's more typical of what you would typically see in a small business or somebody who's starting up a small business, which wasn't my intent. So let me start off just by telling you a little bit about S2o. We're not a big company. We're between 9 and 15 people, depending on how you count, but 9 that are dedicated to this task. And we specialize in whitewater park design. And what that means is we go into a river and we make that river more fun to kayak on. And for a lot of towns and cities that have, throughout the industrialization of America, they've taken that river and stuck it behind a dam and then into a canal and then confined it in a floodway as it goes through these cities. And the cities and towns have started to realize that, look, there's a real economic benefit to opening up that river and bringing people in here as tourists or for parkland and letting them actually touch and feel that river. Reno, Nevada is a great example of that, where we changed the river from being something that was behind a concrete wall to something that's now their central exhibit when you go downtown to check out that city. And so we do that. We also build rivers from scratch. So we build pumped whitewater parks, which we can build as we say, in a Walmart parking lot. And then we also do more traditional things that we just started to diversify our company. So river restoration, floodplain engineering, and other kind of standard, scour analysis for bridges and things like that. We do projects around the world, and part of that has to do with my background, just having connections around the world. But we've done projects in the Middle East and Europe and Canada, New Zealand, and we've been invited to pretty much everywhere, China, Africa, places like that are still working on financing those projects. And so I do without COVID, I do about 70 plane flights in a year. And so COVID was a welcome relief from travel on that front. And here, just to set the stage, this is just some of the parks we've done. This is the London 2012 venue. There's 2 whitewater channels there if you look carefully, and there's a pump station for each. There's actually a tent on top of the second pump station there. It's about a $60 million venue that we built to host those Olympic Games. And we'll talk a lot about that because that was kind of our launch for our company. U.S. National Whitewater Center, a lot of you have been near this anyway. It's in Charlotte, North Carolina. It is the most used and most profitable whitewater park in the world. And that kind of gets to our design methodology. We're a user-based, what I call a user-based design organization. And so we look at how to make not just those Olympic athletes happy, but everybody who shows up. One of our in-stream projects, this was in Eagle, Colorado. It was actually an area that was rerouted by the CDOT, our highways group. And so the river wasn't natural to start with and had a lot of eroding problems. You can see the banks are highly eroded. So we came in and built a whitewater park to add fun and also to fix the issues that they had. So I guess the real question is, how do you end up on this sort of odd career path? I was born into it. I grew up racing kayaks. I started when I was about 5 or 6, and have been racing basically between then and when I finished undergrad in 2000. So about a 20-something year career. I did it professionally. I raced in 3 Olympic Games and was a 3-time World Cup champion. And so just kind of at that top end of the sport and racing throughout the world doing that. And at the same time studying engineering. And so it took me 13 years to get my undergrad. I dropped out 8 times for 3 different Olympic Games and several World Championships. And when I left, my dad did ship design for the Navy. I was going to do ship design for the Navy, and kind of last minute read an article about a guy doing whitewater park design, and basically called him up and said, "You don't know me, I want to do this." And he said, "I do know you. You came to a party at my house once, and I'll hire you." And so just kind of went down that road. And as we did it, I had done a lot of design with Matt, actually, a lot of design theory in grad school and design methodologies, and was realizing that we were building cookie cutter things, and that there was a better way to design these whitewater parks and bring innovation and bring in all these things that we learned in school. And so that's where we started to I started S2o, and we started to do these parks with this user-based design idea, where we're identifying all the different folks who touch a park. And when I say users, not just the rafters, not just the kayakers, but also how does the guy who maintain it? How does the guy who markets it market it? How does the guy who does food service use it? So looking at all those people and designing these things for how they will actually be used by the people that will actually use them, as opposed to just for this guy on the screen who's going to go real fast and look real good on TV, and then when the Olympic Games are over, not come back very often after that. And so we, at my old company, we had built the U.S. National Whitewater Center. That was my project. And then as we started to launch, there was a group that said, we want to do that in a big way. And they put together a $2 billion project in Mesa, Arizona called Waveyard. If you've ever heard about Scope Creek, we started out as a $60 million project that the local city was happy to fund and we should have built. It creeped up to $2 billion and included resorts and retail areas, water parks, surf parks. It was actually, I don't know if you guys have seen that movie about the crash of Wall Street, but essentially these guys were in Lehman Brothers Friday. They got it all approved. Monday they went into Lehman Brothers, September 15th, 2008, and they were sitting in the lobby and crying. People were carrying boxes of things out the door, and they had experienced the crash of the financial markets. Enough said, that project was gone. And in fact, Bear Stearns was the backer of most financing at the level that we needed, and Bear Stearns went out of business. And so not only did we lose our ability to fund this project, but it didn't look like we would be able to fund future projects for some period of time until that was resolved. So that was crushing, right? I just started a company and failed right away. Well, right around then, the phone rang, and London 2012 had a designer that they didn't like, and they'd lost confidence in. They'd done some testing of the design and didn't like it, didn't think it would work. And so they asked us to team up with a local British firm, and they said, look, we want you guys to redesign this, use as much of it as you can, because it's already under construction. So this is the project. The first day I saw it, pump stations going in. So a lot of the variables that we could have controlled for, we couldn't control for. They had been set. The grading was largely done. The earthwork was largely done. And so this had a big red circle around it down at the ODA. And they were essentially saying, we don't know if we can deliver this project on time for the Olympics. And so here we were, a project in crisis, and we were given a project in crisis as our opportunity to survive. I say we, it was I, as a one-person company at that point in time. And I think when you look at career paths and things like that, I don't think opportunity often presents a project that's well-funded, well-formulated, on schedule, and ready to go. And so I suspect that a lot of companies come from places like this, right? If you want to make a bang, you got to roll up your sleeves a little bit. And so we were literally making designs for this project for that day, getting them drawings for that day, and at the same time trying to build this physical model that we had to create, and then trying to build a computer model so that we didn't have to hand draft or essentially draft each page separately. The physical model was I think when you start talking about, hey, how do you bootstrap together an engineering design? We were hired with this, and the requirement was that we build a physical model in 9 weeks and operate it for the Olympic Delivery Authority and the British Canoe Union, who's their national federation. And so this normally you hire a lab, normally it takes 2 to 3 months to get all that done, another 2 to 3 months to build it. And so we basically went and rented a large warehouse here in Boulder. And then how do you build a model that quickly, that accurately? And so we came up with the idea, or I guess I came up with the idea of rapid prototyping. And so I did all of the drawings in Revit at a 1-to-1. And so and then we basically put those drawings on a grid on the ground with a laser, and then laid them out on the grid that they were labeled as. And so that contractor, as he ran around and cut the boards that made up the base is actually fairly complicated to be accurate. As he cut the boards to lay out that base, he's looking at a piece of paper on the ground that says, I need a board here that's 3 foot 7 inches long and has a 36-degree angle on this side and a 95-degree angle on that side, and it's all colored in. So he cuts that board and he puts it on top of the colored in board on the ground, and it either fits or it doesn't. And so they built this thing in about 2.5 weeks, which would normally take a long time. We then repapered to the same grid and laid out the model on top of it. And so you can see here, they're actually building the channel, this physical model, to the paper again and cutting it out along and laying channel. It tells you it had all the information they needed to build it right there. And so these guys that had never seen a whitewater channel before, if you look at the right here, created a highly accurate, within 1/8 of an inch, channel model that was polished and ready for prime time by the time the ODA came in. You can see that there's a lot of, it's a big thing. It was a 10,000 square foot model. It cost about $150,000 to build. There's a lot of infrastructure that goes with it. I learned a lot of lessons here. We're familiar with using gas pumps for the construction that we do. So we use gas pumps, and the first day that we laid it out, everybody got horrible headaches, and I had to call people in the middle of the night to make sure they're still breathing. And so we had to rent about 20 of these fans. Luckily, the warehouse had a door on each side, and so we opened the door and ran the fans full time. Next model we made, we put electric pumps in. You could see those pumps here right in the middle of the warehouse. We had to build a large pond that would contain all the water when we turned it off, and that was deep enough that we didn't suck air from the surface for our pumps. And then a measuring system for that water on top. And so we calibrated the water. We basically pumped more water than we need, and then used a valve to leak the extra water, and then measured it. And this is my forced partner from Great Britain, who's one of my closer friends now in the world. And he and I got along great. At the end, we said, look, we don't know if we had 2 different ways to measure the water. We weren't sure if they were accurate. So we made a box that was a cubic meter, and we timed how long it took to fill up. So that would give us the meters per second pretty accurately. And in the end, we made it, stripped down to our underwear, jumped in and ran 6 measurements, and did an average and figured out whether we had the right flow rate or not. Turned out that we did. And we actually still use that method to check all of our models to this day. When we're done, it was highly effective. The British, had, instead of firing the team they didn't believe in, they promoted them. So they were obviously evaluating us and keen to say that their design was perfect. It wasn't. But by having the physical model, even with that contentiousness in the room, it was easy to say, hey guys, let's all agree that this doesn't work. And these are the British coaches here. This is a Canadian team that actually came in to do research on our model. And these guys are from, this guy's from the Public Delivery Authority. So we were able to just go back and forth to the chalkboard and come to consensus on the 13 major changes we had to make. And then at the same time, very quickly reach consensus on whether we had solved those issues or not. And eventually we did solve those issues and came up with a design that we liked. At the same time, this guy Andy and I were, or had been anyway, drinking a beer as we built this thing and started talking about a better mousetrap. And we had both liked the idea of creating a new obstacle system. The previous system was problematic for a lot of reasons. And could we build this thing and do it in a better way? And in some ways that comes from one of the objectives on the project, which is design a channel system that will be state of the art in 10 years. And what does that even mean, right? I think they have liberal arts majors that come up with crazy things and dump it on engineers all the time. And here we were stuck with this constraint of, I had raced in the Olympics 10, 12 years before the 2012 games, and the sport had completely changed. How did we know, in ways we hadn't foreseen, how did we know what it would look like in 10 more years? And so we started talking about, well, what if you could design a channel that would change with the obstacles? And so this is a traditional channel. This is the one we built in Charlotte. You can see the rocks and concrete are the primary mode of setting up what that river does. And there is this French system that allows you to constrict or not constrict the channel. It doesn't give you a lot of options for reshaping the channel. And so that was state of the art in 2000 and still being used in 2008, 2009 when we were doing this project. And we started to say, look, what if we could put something anywhere in that channel? And this became kind of the nugget of opportunity, I guess, that came out of that 2012 channel to really change the way whitewater parks were done. And so I think you've all done that freshman design class where you create an ideation matrix and you say, okay, I'm going to solve this problem and here's 6 different ways to do it, and then I'm going to solve that problem. We did it. I mean, we did everything. And so how did we get from these blocks, which coincidentally are covered in Velcro? That was the first thing we came up with, is what if they were just Velcro and we could pick them up and move them around, which sounds stupid, and in fact it is completely stupid, but that's where we started on this thing, and this is where we ended. This is the Olympic Games in London. You can see our rapid blocks, a fairly refined system made from polyethylene with parts supplied from all over the world. India and China is a part of that. So how did we get there? And so this is the previous system. I'm putting it in Charlotte. You can ignore that bottle there. I'm sure I didn't drink out of that while I was working. And we basically said, look, the problem with this is it connects in only a few limited places. And to move or make these pegboards is a big deal. Those pegboards require that every one of those cups that it goes into, or slots that these popsicles slide into, be exactly vertical. And if they're not exactly vertical, then these 2 blocks don't fit next to each other, which happens all the time. And you're asking a construction crew out on this big dirty site full of tractors to pour these precast pieces and then get them into the channel without breaking them, and hopefully they're all just ideally aligned and working. In reality, it doesn't work that way, and it doesn't give you a lot of flexibility. And so we started running through these different examples of how we could do it. And we started with the Velcro. We went to bicycle, quick connect bicycle hardware. So, okay, we'll put it in, we'll twist it, and that'll tighten things up. And wouldn't that be great? Turns out that hardware costs an arm and a leg, and nobody's interested in paying that. We looked at all different ways to attach, and things really started to coalesce. We had a lot more prototypes than this, but things really started to coalesce when we discovered the idea of using Unistrut. Unistrut's a commercially available thing. Most buildings you've been in have the wires in the basement attached through Unistrut. Most job sites have a circuit box that's made up of Unistrut hammered into the ground. I'm sure if you walk around your building or your development, you'll see it everywhere. So it's a common and commercially available product with a million different variations. Some of their variations are made to be poured into concrete. Other ones are made to be put into structures like this. And so we were able to take this commercially available system and start to evolve prototypes that would work. And it made a repeatable pattern. At the end of the day, we were able, with some amount of figuring things out, to make them crisscross the same way Legos do. So I can put another row in front and rotate layers so that structurally we have this very, very robust system made from smaller pieces that are connected themselves. We did put it in a river. It did work, and you could tell this wasn't a fun day, cold day, but at the end of the day, we were able to create this eddy, and in fact, the operator of that channel loved the blocks, and eventually redid that entire channel with rapid blocks. So in the long run, they became our client. Instead, though, we were asking them favors to help us put this thing together. You can see that the previous version had concrete obstacles. So that's when it went over to me. For you stresses and strains structures guys and materials guys, I had done a lot of FEA in undergrad and grad school, and so started testing these blocks out, and actually used about 6 or 7 different softwares to do it, and tried a million different shapes. I tried arches, I tried square boxes, I tried smaller obstacles. I tried bigger obstacles, and we ran into some key issues. The biggest one being that plastic is really bad in tension. And the other big one is plastic is really bad in compression. And so, so how do we solve those two issues? And in the end, we created these rods. We basically put this metal, what we call top square, flush with the surface of this block. And that metal component connects by a metal rod to the metal top square and the one below it. Or at the bottom, it connects by that same piece of hardware into the channel itself. We didn't want to have 10 different kinds of hardware to work with. The compression was the hardest part. They were all failing by buckling when you stack these things up. And so, like I said, I tried arches, I tried a bunch of different things, beam structures, things like that within the plastic. And what we came up with is this castellated structure. It looks like a castle. So I don't know if castellated is a real word or we made that up, but this castellated structure was quite effective at resisting that buckling, even with the use of polyethylene. I also designed it, as we started to look at the design, golly, you know, what if there's 1,300 of these in the one Olympic channel, not both of them, just one of them. You know, what if 2 people have to carry every single one? Well, that's a pain in the butt. So we made them exactly the right size so that it weighs, I think, 46 pounds or whatever the weight is that one British person is allowed to pick it up according to their OSHA requirements and carry it around the site. And so, so we designed for that. You know, we designed for assembly, so it fits not only together, but it also fits with our angled obstacles and our slanted obstacles. And so if you look at this, it's 1 meter by a half meter by a quarter meter in dimensions. And it actually lends itself to allowing for some issues we have with sloped channel walls. So this thing can still be flush against the sloped channel wall with those dimensions. We did this design for X, which I'm sure you've all done in school and in work, kind of to the nth degree to make sure that we had everything we needed as we went into this. We started making some serious prototypes. We teamed up with a former sponsor of mine, the Dagger Canoe Company, and we actually looked at, hey, can we make these in China? Can we make these, you know, someplace? You know, what about guys who make garbage cans? Can they make these? And when we went out into the world to talk to plastic manufacturers, everybody said, boy, that's a really hard shape to mold. You should hire kayak manufacturers. They're the best. And it just turns out that the kayak guys have a very hard task making a boat that survives and holds its shape in this whitewater environment. And at the end of the day, we were in the right place with the right people and had the right relationships. And so we made these prototypes. You'll see a bunch of different colors for prototypes. That's because we made them with the leftover plastic that was in the factory from apparently people didn't like orange boats that year. So we got some orange blocks. And so you'll see a bunch of different ones. Some of that actually factored into our success versus failure on the project. The benefits of this polyethylene is you can make a ton of them. You know, they're made to be mass produced. Blow molding would have been better, but it's hard to do that shape in blow molding. The thing we also found is this is a rotomold here. That's an oven. This is the rack that goes into that rotomold that's spinning around here and cooling on the drying rack. When they put that rig together, they hold sea kayaks, which are very long, kind of 15, 16-foot things. But whitewater kayaks are 9 or 10-foot things. And so we were able to take our mold for the rapid blocks and actually bolt it to the mold where there used to be a blank for the smaller whitewater kayaks, which is a big part of this company's business. So they could actually mold a block without significant additional manufacturing costs. There's materials costs, but we were able to fit in the oven when they were doing these other things. And so they were pretty happy to help us out and develop a new line of work, especially given that it just used up what was extra capacity for them anyway. And so this is our final product. These are rapid blocks. You can see the dimensions on there. That's the rod that makes the whole thing work. If it weren't for that, we just basically patented the Lego block, right? But this connection going through from this top square into that top square is what holds all of those tensile loads. This castellated shape is what holds all of those compression loads. This connection works for these blocks as well as our half blocks, and then this other system allows us to connect all kinds of other shapes in there. So it's a very versatile, more versatile than we had actually planned for system. And we brought this back and said, we want to use this. Well, remember again, the guys who got fired were our bosses now. and they were pretty keen to not see the channel work, and they were also pretty keen to see us fail. They were also not engineers. They ran an engineering company from one of them was a music major and one of them was a physical education major, and so it was kind of a weird team to be up against. But they came back and said, you have to get a college professor to endorse this product. And I think we all come from a world where engineers have stamps, and I have a stamp, and I would certainly go to a structural engineer and get a stamp for this. But instead, I had to go back to my old college professor, Dr. Colton, and ask him to do an evaluation of them. We did our report. This is a secret for all of you. We did our report in Maple version 14, which is a terrible software that, unless you know how to use it, doesn't make sense at all to anybody. I think it's more user-friendly now than it was. But it's kind of my secret in engineering when you get something like this, is you write it all in Maple, and we gave it to these guys that had majored in music and physical education, and they read it and said it looked good. I'm sure they didn't know what it meant. And so we went off to build these things, and they said, no, you have to pass a structural test. And so we actually said, I mean, basically the idea was, you're going to fail. And we said, fine, we'll do the testing. And so we had that structural analysis I'd done in Maple. We built this test bed. This is unistrut that's laid in the concrete, the in situ unistrut. We put a load cell that measured the load on this, and then we basically just pulled on this come along until that load matched our calculated load for the project. And in fact, if you take all of this specialized stuff that's there, the failure point, the calculated failure point, is that this unistrut has a pullout strength of 3,000 pounds. We had, if you count the moment arm and all that, we had 3,000 pounds worth of force on it at this point in time. We obviously didn't go any further. We didn't want anybody to have video of it failing. And so when we took it out of the ground, I looked down, and that point there had deformed enough that I suspect had we gone 10 more pounds, it would have popped out right there. They also wanted us to show its ability to, if you think about rafting in a river, you fill up a raft full of water, you fill that up full of 6 people, and then you raft it down a river at some high velocity, and you run into these obstacles constantly. And so they wanted us to test it for impacts as well. And so we built this set of rails. It's basically a sled on rails, and we stacked up the rapid block 6 high. You could see I put a little raft tube here to pad it. It's not an impact, it's an impulse, is how we calculated it. And then we put the weight of all those people in it, and we had to get it up to whatever the velocity was. Took us about 10 tries. And we used a high-speed camera. You could see the tape on the ground here to mark the distances, to measure the velocity as we approach that impact, and we got through it. And so at the end of this, the ICF approved it. We were allowed to use it. Gave ourselves a big pat on the back, and we brought the client, the final owner of the park in London, out to see our test one. My British partner lacks nothing except for style, and he lacks style completely. And so he had built these demo blocks from leftover plastic and then dressed them up essentially as a Coleman cooler. And the lady came out to look at it and said, "You're not putting that in my Olympic channel, no way." And that was almost the end of our company right there, because she had to be coerced that we could do these in any set color. And in the end, we had to let her actually choose the color that these were built in. And so the final product is this. Is this baby blue that matched the colors of the Olympics. You can see the blue around here. We manufactured, I think a total about 1,500 for this client, 1,300 in that channel. At one point in time, again, we identified 13 problems. They allowed us to fix 12 because you could fix the 13th with rapid blocks. When we installed this in the channel, we had made back all of our money. The molds cost about $150,000. We had made back all of our money except for 5,000 pounds. And then so we basically worked for 2 years and lost 5,000 pounds is what it came down to. And then they ran it, and of course that 13th issue that we had brought up turned out to be a real issue. So they bought, I think, 200 or 100 more rapid blocks, and we went from $5,000 in the 5,000 pounds in the hole to 5,000 pounds ahead, and went out and had a steak dinner and a big party, and we were now off and running as the rapid blocks obstacle company. So, when you look at this measure, right? I'll go back one slide, but did we create in London something that was state of the art for 10 years to come? I'll let you decide, I guess, if we did that or not. But at the same time, 4 years later, the Rio Olympics had those rapid blocks in it, and 4 years later, the Tokyo Olympics had those rapid blocks in it. The French venue, which has already been built for the 2024 Olympics, will have those rapid blocks in it, and we have reason to believe actually that 2028 will have those same blocks in it. And so I would assert that not only did we create something that was state of the art in 10 years, we defined what state of the art was 10 years to come. And so pretty exciting project from that standpoint. In fact, it became so popular. This was a course that I raced on. This is Slovakia, and of course in or near Bratislava, I guess, in Slovakia, that had been running since '96. I raced in it in '97 and '99 for the World Cups there. They asked us to come back and redesign their channel just so that it could include, this very famous channel that had held all kinds of major international events, just so that it could include these rapid blocks. And so this is a retrofit to that original design. We've also added things, I call these rapid ramps, but we've created a way now that boaters, one of the problems we have in the winter is we're all barefoot and we all have shorts on. Boaters can now go back up these big drops. This is all AstroTurf. Just by pulling with their hands. There's another one over here, if you look carefully, one there. So they're able to ascend this entire course without getting out of their boats, which allows them to stay warm and also to work on big problems in this area or things like that. So we've started to really evolve into other shapes. There's wedges, there's groin infills, not on this course, that allow us to do that. There's start gates. So really it's allowed us to change that course. And again, I'm taking a lot of credit here for something that both my British partner and I have been involved in. But I'm a big believer that innovation leads to innovation. So once you decide, essentially what did we do? We took whitewater, right? And we reinvented the most basic thing in it, the rock that sits in rivers, right? And made it something that was changeable and adaptable to different systems. He took it a step further. This is a course in New York State that is a swiftwater rescue course. So now first responders come in using that same connection system. There's actually a channel around the outside of this that has those rapid blocks in it. But using that same connection system, we can put vehicles into the flow. And not 80% of rescues for swiftwater rescue or first responders are from vehicles. And so we've got this ability now for them to actually practice that in a controlled environment. They can do it at night, which swiftwater rescue is very dangerous to train for. Nobody's ever done it at night. And so now we have an environment where not only can they do it at night, but every light pole in this entire, not these ones because they're fake, but every light pole in this entire venue has an emergency stop on it that shuts off every pump and turns on all the lights. So somebody goes missing, something happens, you can hammer that button and go figure it out before they get in trouble. You're not going to drown in no water, so it solves that problem. Just to bring it full circle, in particular, because I actually stole this picture from NASA's website. I think there's some lessons to learn from this. Like I said, that no company starts because somebody brought them. Very few companies, I guess, start because somebody brought them the perfect project on a golden platter. Usually, you're working on a shoestring budget. You're working late nights and weekends and things like that, and cobbling things together out of plywood or Velcro or duct tape or whatever it is that you're working on. And so coming up with those innovative ideas that allow you to get something done in an unconventional way, drawings that are one-to-one. We spent $200 every time we built that a new layer of that model just on paper. And so I think those things are very significant. And the other one, I saw a talk, actually, I think I was at Tech when I saw it, from Bert Rutan, who's this guy who does a lot of aerospace innovation. And he talked about, trying to work with different teams on innovation and finding out that, usually there was too many people in the room. And I think this idea of sitting down, on a construction site during a rest break with a bottle of beer in your hand and saying, hey, what if we do this? What if we do that? And I'll say that I do that all the time because my mind wanders while I'm working on projects. And when I do that, most often people in the room are like, that's crazy. Don't do that. That's nuts. Whoever thought of putting the space shuttle on top of a 747 has an incredible amount of guts to open his mouth in a meeting, right? But at the end of the day, that's how you find how you find these solutions. And I would say 99 of my ideas are terrible. But with this Rapid Blocks thing, we had a pretty good one. And what it has done is taken a company that was likely going to fail in the crash of 2008 and turned it into a company that has stable footing and kind of these two different income streams now. And so that's kind of the story of my career. And I will pass it back to Matt. See if you guys have any questions.
Yeah, thanks, Scott. Does anybody have any questions? Just gonna open the floor to people want to raise their hands. I don't know who was first. Khadija, can you want to go first?
Sure. Hi. Thank you for presenting. And one of my questions is when you're going to an environment that is really hot, like for example, when you were originally looking at Arizona or places in the Middle East or Africa, are they asking you to build it indoors? Like for example, the Mall of America and the Water Park of America, which are in Minnesota, they have those indoors just because a huge time of the year you wouldn't be able to use them otherwise, like the theme park or the water park. So
yeah, that's a great question. We get that a lot. And it's economically difficult to, I mean, our venues are 20 acres or so when we build these. And so it's economically difficult to put the whole thing inside, but we've looked at several solutions that allow us to put a portion of it inside. And we haven't built any of those. Some of them were for hot places, but also for Russia, right? Where you might have such a hard freeze in the winter that people aren't able to paddle. There's been a couple interesting solutions there that we've also looked at. One was that we would use, we looked at one venue we were able to, it was located next to a power plant. And so they had a waste stream of heat, their cooling channel basically from their power plant that helps them condense that spent steam. And we had looked at ways to just put a heat exchanger in. And so you can't heat the whole air, but you could heat the water in that environment and make it attractive in the winter. And so we thought that one was interesting as well. But yeah, it's a good question.
You didn't just want to use the power plant's water straight?
I don't know if that was on the table. They didn't want to shut it down, I don't think, but it's a good idea.
I'm just kidding.
Yeah.
Kidding.
little high energy water, yeah. So
yeah. Ryan?
It was really neat to see the sort of secondary applications at the end, especially involved in things like emergency management and that sort of stuff. When you were in the process of designing it, was that something that you kind of had foresight on about potential other uses, whether it was like emergency management or potentially like ecological sort of things?
What really happened there, this goes back to our user-based design, which comes from the lab I was in Matt with, where we really looked at who's the clients of these things and looking at the owner as a client and the marketing department as a client, things like that. And so in our first park, that Charlotte park, that first park that I built, we built an area for rescue training, and we basically went and met with that person who does that and said, look, what's the things that you wish you had all in one place? Because they normally run these classes around a bunch of different places to try different scenarios. And we did that, and then that guy probably never taught a class there because the owners of it had so much business with different fire departments coming in that it became a big deal. In our next couple of channels, we started to say, how do we optimize that? Look at what they actually do. How do we make it better? And so then we're actually talking to firemen, which actually rescue different than kayakers do. And then in the long run, and Andy was the first one to find a client for this. We built a channel, or he built a channel that isn't used for kayaking anymore. It's just used for swiftwater rescue, and that's where he came up with the whole urban flood environment where we flood a village. And there's also some really dangerous things. I didn't talk about it in the picture, but there's some dangerous things that look like slides to people, and so kids in the Midwest a lot of times get stuck in these things and drown. There was just one recently where they were stuck in it for about 18 hours. And it just looks like a fun slide, but I can't swim out. You can't swim out. Nobody can swim out. And so we create that on our site in a place that doesn't kill firemen, and we let them train on that. And it's so it's kind of one of these fun things where we started with something completely different and people started to use it, and then we optimized it for that, and it's become a whole different income stream.
Jonathan?
Yeah, I had a question sort of on the development of the rapid block. And I feel like, a lot of times when you're under, it sounds like that was sort of developed under a tight schedule, right, for London, right, with a really tight deadline. How did you decide to go to a totally new architecture versus try to get what worked? I feel like a lot of times at NASA, we'd sort of try to plug in a few innovations that are sort of incremental on, how do we use what sort of worked in the past and then, that versus totally redesign. How did you decide to take that risk? And
yeah, I would say you're wiser than I was when we did this. We've had as many bad ideas as we've had good ideas, and some of them have really bit us in the butt on things. And this was done rapidly and on a low budget, and it could have been something that was a dramatic failure. It didn't turn out to be, but you're right. It was high risk, and especially in such a something where there's so much optics on that actual channel system that you're right. We probably should have thought that one through, but NASA should too. I'm glad you do it the way you do it.
Was there a backup option if the rapid blocks wouldn't have worked, or would they have had to cancel the whitewater event at the London campus?
We had done a lot of testing, so we knew that they would work. What we were worried about was our cost, because we had to build molds for it and all that. Our cost for that first set of them was only economically feasible if we used the very minimum amount compared to this French group. And what we knew was that French group, on the 3 projects we built with them, they give you one price, and then when you go to buy them, that price is higher. So they win the bid, and then you design it for their stuff, and the price of plastic's gone up, so you're gonna have to pay more. And so, but that happens every time, and so we were wary of that. So we were chasing this straw man price that they had put out there. But what we also knew was that these rapid blocks, you lay them in a channel and they have a certain strength. That those 6 that we had up there that we had the load cell on, if you put them on a wall and hung a Mini Cooper from it, it would hold a Mini Cooper. It's incredibly strong, those blocks. At the same time, what we knew is that if you interlock them, they get a lot stronger. And so if you look at that London project, all of those blocks are single rows. If we had trouble, the backup was you would just put in 2 rows and you would interlock them with each layer. And then that structure becomes, the moment arm, of course, becomes a lot stronger. And the structure, itself gets stronger too. So we did have a backup plan. It was more blocks.
Cool.
Khadijah's got her hand up.
Yeah, I had another question. So, in areas where it's a desert, have you investigated using salt water, or would that have any issues with corrosion on your system?
Corrosion's an issue, and in fact, we're now using stainless steel for a lot of those parts that were initially galvanized. There's actually one of the issues we have. For example, London has stainless steel, and we did. I don't know how we got on this, but we got to reading about it one night, and we got really worried that we would be the sacrificial anode. The blocks would be the sacrificial anode to that stainless steel, and so we insulated those. There's actually a little nylon washer there between the rods and the base of the concrete that prevents there from being a cathodic reaction there. But there are channels that are saltwater. Very few of them. The Athens 2004 games where the pumps, for example, suffer from that. The rebar and the concrete also suffers from that, and so you have to get bronze pump heads and epoxy coated rebar and things like that fight corrosion. So saltwater is very feasible, but it would require us to spend a little extra money to deal with that. The good thing about saltwater is it treats itself, right? Saltwater is a treated product, and if you exchange it with the ocean, that can work very well. And so you're really kind of having fresh saltwater come through your system, also cooling it, things like that. But it does lend to these other issues that you have to design for.
Ryan?
Especially given your background as an athlete, what were some of your guiding thoughts in terms of the safety of the system? And were there any particular design features that you incorporated into it to kind of help out the athletes in that regard?
Sure. The big one for athletes is drowning, right? In our sport, drowning is an issue. And the way you drown or get injured in a natural river system is you'll have a gap between the rocks, or 2 rocks that are very close to each other, and you'll get an appendage between those 2 gaps. And And you can imagine, if there were two rocks here and my foot got stuck between it and I rolled over it, it would break my leg, and then I would troll, in sort of a cantilever position there. And so we were very conscious of getting rid of all those gaps. And that was one of the faults of that other system, is if all those little slots that they factor or that they slide them into were not exactly lined up, you do open up, and it doesn't take much of a degree of difference over that 6 feet high, and you have a gap there that a baby's arm will fit through or something like that. And so that's one of the risk factors that people had been trying to address with the old system that we felt like the rapid blocks really addressed, because not only are we not sitting in a slot where we can wiggle around and open up gaps, but we were also bolted firmly in place, and we can ensure that those gaps aren't there. And so that was one of the big ones. If you look at those, the other one's impact. So if you look at those rounded lids, they're designed to allow someone to, for example, to fall out of a raft and hit those. But the good thing about a pumped channel system is you can turn it off, so it's hard to drown when you're dry, and also when you do turn it off, within a matter of minutes, that water pressure goes way down. And so some of those bigger risks that you worry about, for example, with drowning or something like that, you've got all these people in life jackets and helmets in probably the most safe river environment, because it's not random boulders that they could possibly be in.
Anybody else? Any other questions?
Yeah. So for a newbie or a novice, where would you recommend in the U.S. that somebody go to try out, whitewater rafting or this high type of kayaking?
I think a lot of you are East Coast people, and so Charlotte's a great, that first venue we built, the U.S. National Whitewater Center. So it's usnwc.org, I believe. That's a great venue to go do it. It's a warm weather sport, so if you can't get there in the next month, then wait till spring. But that's a great one. There's also just everywhere you look along that eastern seaboard, and as well in California and Washington State along the western, where the Rockies are, there are rafting companies there. So you can likely find, unless you're in Florida, you can likely find something within reach to go do. And so we're about to build one in Montgomery. We're actually halfway through one in Montgomery, Alabama right now, so not too far from one of the NASA installations there. And so when we get that done, come visit, and we'll throw you in a boat.
Yeah, that's not too far from Houston. Thanks for that information.
Yeah, I have a question. How much were these blocks inspired by Legos?
Well, not much. And at the end of the day, when we wrote the patent, I wrote it, and then we got a patent attorney who you can barely talk to for how much they cost, right? Every minute you spend talking to that guy, he's billed. And he wrote the patent language himself. He rewrote it. And when I read it, I was like, golly, it sounds like a Lego, But there were some real advantages. We didn't look at the Lego for dimensions. We probably should have, because the Lego is incredibly, what you realize afterwards, it's incredibly compatible. But one of the things that turns out is that our channels aren't all vertical walls. In some places, they have a wall that's a 3 vertical to 2 horizontal slope to it, which has some benefits for slope stability and things. And so we have to fill that gap. Well, it turns out that we can make a half-height, it's called a groin, it's a French word, but it's a half-height wedge that fits in there. And with our with our system of 1 meter by half meter by a quarter meter, we can stack up 3 blocks and then overlap that one. So it's very securely held in by our system from the top. And then we do 3 more blocks and fill it in, and that fills in that entire wedge. And so we were really sort of serendipitous with the shape we chose, which I guarantee you was 100% related to making sure that it was less than 46 pounds or whatever the British required for their OSHA requirements. But it turned out to be very serendipitous. And we've had other clients come back and say, can you retrofit our channel like Bratislava? And I've said, well, we'll just custom make an obstacle. And then you try and solve that same problem with our blocks, and it doesn't fit whatever their slope is. It has to be that 3-2. So something we never checked, but it turned out to be exactly right. So yeah, we're very close to Legos, I think, and there's a lot of reasons why.
Yeah, Yeah, I was just wondering. I think I saw a paper somewhere where someone was like showing all the advantages, whether they were accidental or intentional, in the way Lego bricks are designed. I was curious if there was a relation there between the two.
When we do trade shows, we make a little fake channel, actually with 2 trash cans for sumps for water, and then we run water through it, and we let kids move. We use Lego, those big boards they have for the base, and then we let them change the rapids, to demonstrate our system. And yeah, the Legos do really well as rapid blocks. So.
So I have one other question that actually, since I saw what you've been doing with S2o, I've been wondering about this. So you showed that wooden model for your first park. Do you still build wooden models for everyone?
So I actually raced with a guy from the Czech Republic who's a professor at the Czech Technical University in Prague, and he runs a laboratory that does physical modeling for dams and canals and all these things. And so we started to work with him. They actually build them for us now. And if you look at that infrastructure page, there's a lot there, right? We have a huge tank that all the water pours into. It has to be a certain depth to be able to pump out of it, to not suck air down from the surface. And that takes our whole model and lifts it up by 6 feet, right? So now we're building a channel up in the air. We have to bring an electrician to install electrical pumps because we don't use the gas ones anymore. So we're $60,000 into infrastructure. Their laboratory, the whole floor is over a pool of water, and so anywhere you want, you can lift up the floor and pour water down a hole into their sump, which is permanent treated water, and then they have water coming out of basically pipes in the roof or pipes out of the floor anywhere you want that you can feed that water into. And so for them, it's very cheap. They just built the channel, and it's kind of down at waist height where we all live and work, as opposed to up in the air. And so we now use that. And I actually spent the last during COVID about 6 months as a specially invited person to the Czech Republic, building models in that laboratory in Czech, or in Prague, I guess, on lockdown, because we had another nation that really wanted those and had political chutzpah to pull that off. So I was the only guy not the only guy on my plane, but one of the only people on my plane flying over there.
Interesting. We got a couple minutes left. Does anybody else have a question? Well, Scott. Oh, Brian's got another one. Brian, go ahead.
It just want kind of a parting comment. It was really great listening to the story and everything, and I guess it's really notable to me that you've mentioned a few times you worked with a person that you raced with, a former professor, things like that. So just the network that you were able to make over the course of your career sounds like it really helped to the success of the project. And you mentioned it was non-traditional to start with, but that certainly sounds like you had a great foundation for success.
The Whitewater Mafia, yes. Yeah, it's been good to have that. And also, we all see this at high school, right? You graduate high school and you go away in the world, and maybe you see those people 2 more times in your life at reunions or something. And so I spent 27 years racing kayaks with people from all over the world, and when they retire, they disappear from your life. I don't make it back to Malaysia to paddle with Sal, or back to Slovakia to paddle with friends there, things like that. And so to have this second career where I'm in their country and meeting these old friends again has been fantastic.
Yeah, that's cool. And Brady had a comment on here. This is a really outside of our wheelhouse, the SLAMS wheelhouse, but this is really interesting to see. I guess I'm a little biased, Scott, but anyways, just want to say thank you for coming and talk to us today. And if it's okay with you, if anybody else has any other questions, I might put out there your email so people can get in touch with you, and your website. But I really appreciate you coming to talk to us today.
Guys, thanks so much. Best of luck with everything, and I appreciate you having me on.
Thanks. All right. Thanks, everybody. We'll see you next month.
Thank you.